How can we determine whether two matrices are similar? As we will see in this video, this may be easy in some cases. Similar matrices have the same determinant, so if that A is not equal to that B, we know that A is not similar to B. This is, however, a necessary but not a sufficient condition. So if that E equals that B, it will take some effort to figure out whether A and B are similar, but we can do it, as we'll see in this video. We'll start with matrices A and B over here, wonder whether they are similar or not. A 1, 2, 3, 4, B 2, 4, 4, 5. Well, it's always good to check the determinants first, and we see that A equals 4 minus 6 equals minus 2, that B equals 10 minus 16 equals minus 6. So I know I don't have to look at anything else. A is not similar to B because the determinants are not the same. Let's look at the next example, A and B over here. That A equals minus 10 minus 12 equals plus 12 equals 2. And here we have minus 28 minus 30, so plus 30 equals 2. So the determinants are the same. So in this case it could be that A is similar to B. But how are we going to figure that out? What are we going to do? Well, one way to do this, which you can do for 2 by 2 matrices, and you will see why it's not so convenient for larger matrices as well. Try to find a P such that A times P equals B times B. So you want to find a P, so matrix ABCD over here, which is invertible, such that A times P equals P times B. So how are we going to find it? Are we going to try? Well, I don't think that's a good idea. Let's just compute for this general P, A times P and P times B. So that's what we're doing over here, A times P. So by the row column rule, we get minus 2A plus 6C as a first element, and then we continue with the other ones, minus 2A plus 5C, minus 2B plus 6D over there, and minus 2B plus 5D over there. So that is A times B. And we also compute B times B, so B times B, and we find minus 4A minus 2B, minus 4C minus 10D, 3A plus 7B, and finally 3C plus 7D over there. And then we have the matrix B times B. Well, those two matrices over here, they have to be the same. So the two matrices are only the same if all entries are the same. So that means that those 4 entries all have to be the same. So minus 2A plus 6C equals minus 4A minus 10B. That equation over there. And you also have the 3 other entries. They all have to be equal. And now you see something nice. What do we have? We have 4 unknowns, A, B, C, and D, and 4 linear equations. So we have a linear system of equations, and we know how to solve it. Of course, you have to clean it up a bit, put all the A's and the B's and C's and D's to one side, and then on the other side you have 0, so you have a homogeneous system. And you can try to solve it. Well, skip those steps, go straight to the solution. And it turns out that in fact it does have a solution. B and C are free, and A and D are given over there in terms of B and C. And then I can try to make a choice such that I find an invertible P over here. Of course, I can take B and C are free, so I can take them 0, then A and B, D are also 0, but that would yield a 0 matrix, which is not invertible. So let's make another choice and try to find an invertible P. So I could take C equals 0 and B to 1, and it follows that D equals minus 1 and A equals minus 5, and we get the P over here, determinant of this P equals 5, so it's invertible. So we have found an invertible P such that A times B equals P times B. Wow, this is a very long calculation, and we skipped some steps over here, so it's good to check afterwards. So compute A times P and P times B. Well, let's do this one. And we get a 10, here minus 2, minus 6, minus 8, minus 2, minus 5, minus 7, so A times P, And finally p times b. 20 minus 10, 10. 0 plus 10, 10. Minus 15 plus 7 minus 8. 0 minus 7 minus 7. And we see indeed a times p equals p times b. So didn't make any mistakes. And indeed we have found out that this matrix A and this matrix B are similar. So you see, this is a way to figure out whether matrices are similar, but it's quite a lot of work, as you have noticed.